Hello everyone, I hope you all are doing well. Welcome back to the AWS AI Engineer Essential series. My name is Dheeraj Choudhary, and today it's time to understand the most critical part of any machine learning project, that is model training. Let's dive in. Let's start by understanding the fundamental difference between traditional machine learning training and cloud-based training. In traditional local training, everything happens on your laptop or workstation. Your data set is stored on your local hard drive. You train the model using your laptop CPU or maybe local GPU if you have one, and the final trained model is saved back to your local file system. The problem is you are limited by your hardware. If you only have 16 GB of RAM, you can't train on datasets larger than that. If you don't have a GPU, training is going to take forever. In cloud training, the workflow is completely different. Your dataset lives in S3, which can store terabytes of data. When you are ready to train, AWS spins up a powerful instance with multiple GPUs and tons of memory. The training happens on this temporary cloud instance, and when it's done, the trained model is saved back to your S3 bucket, and then the instance automatically shuts down and disappears. The beauty of cloud training is on-demand compute. You don't need to own expensive GPU hardware that sits idle for 90% of time. You rent exactly the compute power you need only when you are going to work on it. A $30,000 workstation with 4 GPUs sits unused most of the time, but in cloud, you may pay $50 for the 5 hours you actually use those GPUs for training. The cost model is powerful. You pay only for the training time, not for the hardware sitting idle. If your model trains in 3 hours, you pay only for 3 hours. If it trains in 30 minutes, you pay for 30 minutes. So there is no wasted cost on idle infrastructure. Let me walk you through exactly how model training works in cloud step by step. Step 1 is uploading your data to an S3 bucket. In our previous video, I showed you after you have done your data pipeline thing, you are going to export that into S3 bucket. So this could be a CSV file, images organized in folders, text documents, whatever your model is going to need for training. The data is going to sit in S3, which is durable, highly available, and accessible from anywhere in AWS. You typically organize your data with clear structure, maybe a training folder and a validation folder. Step 2 is launching a training job. You specify what type of instance you want. Maybe it can be a G4 instance or X large instance with one CPU, or it can be with 4 CPUs for faster training. You also point to your training code, which could be a Python script you wrote, and tell AWS where in S3 your training data is located. So you submit this training job through the SageMaker console, SDK, or even CLI. Now, step 3 is where AWS takes over and does the heavy lifting for you automatically. AWS provisions the exact instance you requested for, which takes about 2 to 3 minutes. It downloads your training data from the S3 onto the instance local storage for fast access. It loads your training code into a Docker container and starts executing it. So your code reads the data, trains the model, and save checkpoints along the way. By any chance, if the server goes down, if it is a spot instance, so this checkpoint helps to start from the same point where it stopped. Then step 4 happens when training completes. Your training code saves the final model artifact like the trained weights, configuration files, and any pre-processing objects to a location that AWS automatically uploads to in your S3 bucket. Once the upload finishes, AWS terminates the training instance completely. You are no longer paying for compute. The trained model sits safely in S3 bucket, ready to be deployed or downloaded based on your requirement. Now the entire process is automated. You never manually SSH into the instances, copy files around, or worry about shutting things down. You just submit a training job and AWS is going to orchestrate this entire end-to-end flow that I just showed for you. Now let's dive deeper into SageMaker, specifically orchestration of this specific training process. At the core is the concept of a training job. A training job is SageMaker's managed way of executing your machine learning training. When you submit a training job, you are telling SageMaker what to run, where the data is, and what instance type to use. SageMaker handles all the infrastructure provisioning, execution, and cleanup automatically for you. Then everything is going to run inside a container. Why? A container is a lightweight virtual machine that packages your code together with all its dependencies like Python libraries, frameworks, like TensorFlow or PyTorch, system libraries, everything needed to run your training script. This ensures your code runs consistently regardless of underlying hardware. SageMaker supports pre-built containers also. For popular framework, you can also bring your own custom containers too. Then SageMaker uses the concept of input channel to get data into your training container. An input channel is training channel pointing to the S3 bucket for getting the train data, and the validation channel pointing to the validation bucket. As I said, once you are going to clean your data, you are going to after that you are going to keep your training data separate, validation is separate, and test separate. Now SageMaker automatically downloads this data from S3 and makes it available at standard paths inside the container where your code can be accessed. Now, when your training completes, SageMaker looks for model artifact, your code saved to a specific directory inside the container. It automatically compresses these files into a tar.gz file and uploads them back to S3 location, which we have specified when creating the training job. This means your trained model is safely persisted even though the training instance and container are about to be deleted. Let's look inside a training container to understand where everything lives and how your code accessed the data. So SageMaker uses a standardized directory structure that every container follows. So when you understand this structure, writing training code becomes much simpler because you know exactly where to read the data from and where to save your model. So the path that you see over here, so this is where all your input channel comes from. Now, so suppose if you want to point to training input channel, so slash data and it will be training over here. For validation, slash validation over here. So like if you have validation channel, you can just change that, and your training script just reads from these standard paths and doesn't need to know anything about S3 or data downloading. So SageMaker handled all that before your code has started. Now, the other directory is where you must save your trained model artifacts. So anything you write to this directory gets automatically uploaded to the S3 when the training is going to finish. This typically includes your model weight files, a model architecture definition, any pre-processing objects like scalars or encoders, and a configuration file with hyperparameters. Then your training script itself lives in this specific location. This is where SageMaker places your Python script or the contents of your source directory. When the container starts, it executes the script at this location. This is the location where your container is going to start. With any hyperparameters you have specified passed or any command line arguments. Then comes last path, which is for logs and metrics and for debugging information. If your training fails, error log goes over there. If you want to save training metrics or validation results, you can write them here and they will be available in CloudWatch logs for troubleshooting. Now let's talk about Estimator, which is the high-level abstraction of SageMaker, uh, which provides us for making the training jobs easier to work with. An estimator is nothing but a Python class in SageMaker SDK that wraps all the complexity of creating and managing training jobs for you. Instead of manually specifying container images, data channels, hyperparameters, and output location with the low-level API calls, you just create an estimator object and call its fit method. The estimator handles all the details for you. So estimators automatically handle several tedious tasks. They select the appropriate Docker container for you from the framework and version. They upload your data script to S3 if it's not already there. They create the training job with the right configuration. They pull the job status and stream logs to your notebook. They even download the trained model for you if you want. The generic estimator class is used when you are bringing your own completely custom training script and container. You have full control, but you need to specify more configuration. So this is useful for specialized algorithm or when you have custom dependencies. So framework specific estimators like PyTorch, TensorFlow, and SKLearns are pre-configured for those frameworks. A PyTorch estimator already knows which container image to use, what Python version is compatible, and how to structure the training data. You just provide your PyTorch training script and data location. These framework estimators make it incredibly easy to take existing PyTorch or TensorFlow code and run it on scale with SageMaker with minimal changes. Now let me trace the complete data flow from raw data to the trained model in SageMaker. So before you start training, you upload your datasets to S3 as one-time operation. This might be the CSV files or thousands of images, text documents, whatever your model needs. You organize this data logically in S3 buckets and folders, maybe separating training or validation sets. So this data stays in S3 and can be reused for multiple training experiments without re-uploading. During the training job, SageMaker copies your data from S3 bucket to the local instance. This is important for performance. Reading data over the network from S3 for every training batch would be too slow. By copying data to the local NVMe SSD storage first, your training code can read batches very quickly compared to reading it from S3. And for larger datasets that don't fit on your local storage, SageMaker also supports streaming data directly from S3, but local copy is always faster when we are going to have it. After training completes, your training script has saved model artifacts to the model directory that I already showed you. I hope you remember it is going to be opt/ml/model. So it is going to save inside the container at the specific location, and SageMaker automatically takes everything in that directory, packages into a compressed tar.gz file and uploads that back to the S3 location that we have specified while creating the training job. This happens automatically. You don't write any S3 upload code. Now the result is a trained model safely stored in S3, ready for our next steps. You can download it for local testing, deploy it to SageMaker endpoints for real-time predictions, use it for batch transformation jobs, for processing large data sets, or even share it with team members who can deploy it to different environments. The training instance is gone, costing you nothing, but your valuable model artifact are going to be persisted in the S3 bucket. Let's understand the life cycle of training job from the moment you submit it until the completion. When you first submit a training job, it enters the pending state. This means the job is queued in the SageMaker system, waiting for computer resources to be available. In most AWS regions with normal load, pending lasts just seconds. But during periods of high demand, if you are requesting many large GPUs instance simultaneously, pending might last for few minutes. So it depends on the availability. Next comes the starting state, where several things happens in parallel. SageMaker provisions the EC2 instance type you requested for, which is going to take 2 to 3 minutes. It is going to pull the Docker container image from Amazon ECR, which is AWS Container Registry. It downloads your training data from S3 to instance local storage. It also downloads your training script if you have provided your custom training script in the S3 bucket, and you can watch progress through CloudWatch logs during this phase. Then comes the training state, is when your actual code is going to execute. SageMaker starts your container, runs your training script with hyperparameters that you have specified. This is where the GPU or CPU is actually going to work to optimize your model. Your script logs appear in real time in CloudWatch. Training duration depends entirely on your dataset size, model complexity, and hardware. It could be minutes or hours. Now finally the job reaches either the complete or failed state. If completed successfully, SageMaker uploads the model artifact to the S3 bucket and marks the job as complete and terminates the instance for you. You stop paying for compute at that point itself. The SageMaker still terminates the instance but saves the error logs to help you debug what went wrong. So either way, the instance is gone. You are not no longer going to pay for it. And now let's understand why SageMaker container-based architecture is so powerful for machine learning workflow. There is a reason for it. Reproducibility is one of the biggest challenge in machine learning. Have you ever hard coded the that worked on your laptop but broke when a colleague is trying to run it because they have different libraries versioned? With containers, the exact same environment is going to run everywhere. The container image includes specific versions of Python, TensorFlow, CUDA, everything that you're going to use. When you share your container or use AWS pre-built ones, you get identical behavior on any instance in any region 6 months from now. This makes research reproducible and models deployable with confidence. Stability or not stability, scalability becomes trivial with this architecture. If you want to try 10 different hyperparameter combinations, you can launch 10 identical training jobs in parallel, each using the same container but with different hyperparameters. They all run simultaneously on separate instances. In an hour, you get the results that would have taken 10 hours for you. So this dramatic acceleration, experimentation, and hyperparameter tuning is also an added advantage. Now, cost efficiency is baked into the design. Traditional machine learning setup requires expensive GPU workstation that sits idle most of the time, as we discussed. With SageMaker architecture, instances only exist during the active training. Submit a job, instance spins up, trains your model, saves the results, and terminates. You pay for maybe 2 hours of GPU time instead of owning a GPU that's used 10% of the time. So for most team, this cuts the machine learning infrastructure cost by 80 to 90%. Then flexibility means you can switch instances types without changing your code. Today, your prototype on a smaller CPU instance that cost pennies. Tomorrow, you scale to a bigger instance, which might be with GPU for production training. So your training script doesn't change. It's the same container running on different hardware. This lets you right size the compute to your current needs without refactoring your code. And that wraps our today's tutorial. If you enjoyed this video and want to keep learning step by step, make sure to like the video, subscribe to my channel, and hit the bell icon so you don't miss the upcoming interesting tutorials. Thanks for watching, and I will see you in the next video.